How many stars are there? For centuries, man's concept of space was based upon what he could see with the unaided eye, a field limited to a few thousand stars. But about 400 years ago, a tool was found which enabled man to roam the uncharted pathways of outer space. It was Galileo who thought of turning a telescope toward the heavens, and in so doing, he snapped the fetters binding man to earth.
I betook myself to observation of the heavenly bodies. And first of all, I viewed the moon, as near as if it were scarcely 2 semi-diameters of the earth distant. After the moon, I observed the heavenly bodies, both fixed stars and planets, with incredible delight.
The telescope grew rapidly in size as astronomy and the science of optics progressed hand in hand. Through the passing years, man dreamed and built. And with the completion of the 100-inch telescope at Mount Wilson, California, he could look with unbelieving wonder at even more of the handiwork of God. And man dreamed again and built yet again the giant of Palomar, a giant whose 500 tons of glass and steel are poised so delicately the hand of a child can move it on its course. A giant whose 200-inch eye stares, unblinking, into space. An eye that is daily pushing back the boundaries of man's knowledge. So how many stars are there? The sun is the #1 star as far as we're concerned. To us, it doesn't look like the other stars in the sky, but that's because we're so much closer to it than to any of the others. We're only 93 million miles from the sun. That's a lot of miles, but it's still very close when we're thinking of astronomical distances. The reason our Earth is so close to the sun is that it's one of the sun's family. That is, one of the 9 planets that revolve around the sun and make up what we call the solar system. It isn't possible in a view like this to represent the true scale in either size or distance. So let's compare them accurately as to size. We will see them here superimposed over an actual time-lapse photograph of the edge of the sun, with prominences extending thousands of miles into space. Closest to the sun is Mercury, just a little fellow as planets go. Then there's Venus, the Earth, and Mars. That big fellow is Jupiter, 1,280 times the size of the Earth. Then comes Saturn, Uranus, Neptune, and poor little Pluto, way out in the cold, going around in a great big orbit, averaging 3,675,000,000 miles away from the sun. But that sun, just how large is it? Well, if it were hollow, you could drop more than 1 million spheres the size of our Earth down inside and rattle them around. For the sun is about 1,500,000 times larger than the Earth. But away out there in the heavens are other stars so much larger, they make our sun but a mere speck in comparison. How far away are they? Well, let's take a trip from the sun just to the nearest star out in space. To make this journey, we'll travel at the speed of light, 186,000 miles a second. At this speed, you could make 7 complete trips around the world in less time than it would take for just one good sneeze. Let's say we begin our journey on January 1st. At exactly 12 o'clock noon, we leave the sun and hurtle into space at this inconceivable speed. We pass the orbits of Mercury, Venus, and span the 93 million miles that separate the Earth from the sun in just 8 minutes, 19 seconds. We continue on, passing Mars, Jupiter, Saturn, Uranus, Neptune, And finally, we reach Pluto, the last sentinel outpost of our solar system at 5:31. And remember, we have traveled 3,675,000,000 miles already, and it's still January 1st. But wait a minute. Our journey was to the nearest star, not to the limits of the solar system. We haven't even started our trip yet. We must continue to travel as the days, the weeks, and the months pass. Finally, a whole year goes by. Then 2 years, 3, 4 years. And on April 19th of the 5th year, we reach Alpha Centauri, that nearest visible star out there in space. To use the astronomer's language, we've traveled 4 3/10 light years. But our telescopes don't stop here. Their searching eyes have probed the depths of space thousands, millions, yes, hundreds of millions of light years, and still there are stars beyond. This tremendous knowledge is relatively new because not too many years ago, astronomers were unable to conceive of anything beyond our own Milky Way system. To them, this was the universe. Then a new discovery rocked the astronomical world to its foundations. For years, telescopes had revealed hazy objects called nebulae distributed throughout the heavens. Some of these, such as the Flame Nebula in the constellation of Orion, which under ideal conditions may be seen with the naked eye, and the spectacular Filamentous Nebula in Cygnus, were known to be composed of luminous gas. Many had a definite spiral shape, thought then to be great whirlpools of luminous gas in the process of forming into a star. However, an intensive study was begun of the great spiral nebula in Andromeda. Bringing to bear the superb resolving power of the 100-inch telescope, this nebula was found to be made up of individual stars and was in reality another galaxy. It was this discovery that pushed back the boundaries of our knowledge and expanded enormously our concept of the material universe. This new knowledge enabled us to understand the structure of our own galaxy. And at last, we had an explanation for the Milky Way. Our galactic system is very similar to the Andromeda galaxy. Seen from the edge, it would appear something like this. The Milky Way is merely our view of our own galaxy. Its diameter is about 100,000 light years, and we are located about 33,000 light years from the center. This system is revolving, and our speed in it is about 200 miles a second. Even at this speed, it will take us at least 200 million years to make one revolution. But ours is just one island universe. How many more are there? Everywhere we look out in space, there are others. There are at least 200 million of these galaxies just within the range of the Palomar telescope. In this amazing photograph made with the 200-inch telescope, the brighter spots are stars in our own galaxy. Let's blot these out. Now, those hazy little spots remaining are not stars. Each is another galaxy almost 1 billion light years away. Each is composed of 100 billion suns. But now, how many stars are there? Astronomers tell us there are at least 100 billion stars in our galaxy, the Milky Way. But remember, there are 200 million of these galaxies within known space. So if we would number just those stars within the range of our present telescopes, we must multiply 100 billion times 200 million. And this equals 20 quintillion stars. But remember now, these calculations are based on those stars which are visible with optical telescopes. Recent developments have given astronomers a radically new tool, the radio telescope. These giants not only detect stars invisible to optical telescopes, they probe several times as far into the depths of space. So our estimate of 20 quintillion stars is much too low. We must be prepared to add billions upon billions more as man's knowledge of the universe continues to grow. Now, of course, the human mind cannot begin to grasp the meaning of such a number. But maybe this will help. Think for a moment, if you can, how many grains of sand there are. Sir James Jeans tells us that the total number of stars is probably something like the total number of grains of sand on all the seashores of all the world. So how many stars? God alone knows the answer. Man may never know the exact number, but each time he looks and sees what lies beyond, he must ever be mindful of the infinite power that put it there. Mexican settlers called him El Carpintero, the carpenter. His scientific name, Melanerpes formicivorus, meaning creeping black thing that eats ants. To bird watchers, he's the acorn woodpecker. A carpenter in a clown costume. But don't let the clown face fool you. Here's a tireless worker who really knows his job, hole digging. Each of these little dimples is a hole, and in nearly every hole there is an acorn, neatly fitted. This is El Carpintero's winter pantry. God has given this high-powered operator all the right tools. Strong toes and claws, that sharp, hard beak, and heavy neck muscles. His tail feathers are unusually stiff. They give him something to sit on while he works. He uses his tail for balance when he flies, too. After he drills a hole, he goes out looking for an acorn. One acorn, one mouthful. These acorns are each about an inch long. Acorn woodpeckers eat more than just acorns. They like other kinds of nuts, some fruits, lots of insects. In fact, like flycatchers, they make occasional side trips to snatch a flying insect. Fancy wing work. They're not particular about their food, and they're not particular about where they store their food either. Any old pole will do. So will a post. Or a roof even. This bird obviously doesn't care if the roof leaks. What's a roof for, except to store acorns? Sometimes the woodpeckers do real damage. It's not on purpose, of course. For the most part, these are very helpful birds, and so they're protected by law. The bird sticks the acorn in point first, and he insists on a perfect fit. There. That one's in to stay. But now, wait a minute. One little woodpecker couldn't possibly eat all those acorns in one winter. And that's just fine with the Stellar Jay, because he likes acorns too. This western relative of the blue jay eats lots of them. So does the gray squirrel. He forages on the ground, but mostly he's a tree-dwelling animal. There must be some lunch around here somewhere. On the other hand, maybe lunch is up here. Aha! Smorgasbord. That woodpecker really jams these things in. At last. It's all right when these other creatures steal the acorns. The woodpecker has more than enough to last the winter. And winter, when it comes, will bring problems. Not just the leaves fall, the ripe acorns do too. The leaves cover them, making them hard for the animals to find. Even out in the open, they're hard to spot. But God, through one little creature, has provided for others. Those good ripe acorns are buried for sure now. Along with the leaves, most of them will decay over the winter. Many birds and some animals migrate to warmer places for the winter. The jays, the squirrels, and the woodpeckers stay. But they'll have enough to eat thanks to the carpenter's hard work. All those acorns are stored well above the snowy ground and easy to reach. And winter doesn't last forever, you know. With melting snow, another cycle begins. What's this? Storing acorns already? They're not ripe yet. No, the woodpecker's digging a big hole this time, a nest hole. This little bird eats half his weight in food every day. Delicious morsels like fat grubs and squiggly insects. As soon as he graduates from hole to trunk, the young woodpecker digs right in. No one teaches him how to drill the holes all the right size. In fact, no one told him acorns are good to eat. He has not yet seen a winter, no snow, no ice. And yet, he's getting ready, just like the other woodpeckers, storing those acorns. Many animals find food in winter because of this clown-faced carpenter. Does the woodpecker realize what he's doing? Probably not. He just works on, using the amazing specialty God has given him. In an immense universe, stretching through the vastness of space, is our nearest neighbor, the moon. Man actually has walked on its dry, dusty surface. We now know it is barren, desolate, devoid of even the simplest forms of life. What a contrast to our planet Earth, a sphere of striking beauty, fresh, fertile, green, and teeming with life in great abundance. What makes the difference between the lifeless moon and the living Earth? Water makes the difference. There's nothing else like water in the entire universe. And yet on Earth there's a great abundance of it. It covers about 70% of the Earth's surface. That's an estimated 326 million cubic miles of water. If the surface of the Earth were perfectly smooth, the waters of the ocean would cover our planet to a depth of between 8 and 9,000 feet. And while it's true that only a fraction of all the water on Earth can be called fresh water, or water suitable for our own personal use, that fresh water comes to us through a water cycle that daily lifts from the oceans millions of tons of water, leaving behind the salt and dropping the fresh water as rain upon the earth. In the water cycle, water vapor is created by the heat of the sun. And the water, the sun, the air, and the force of gravity work together as they have for centuries to keep what is known as the water cycle going. Warm air is lighter than cold air, which causes it to rise. These clouds began as rising currents of warm air laden with moisture. Prevailing winds help the process along by pushing the moist air up steep mountain slopes. As the air rises, it cools. And as it cools, it contracts, literally squeezing out its moisture, which falls to the earth as refreshing rain. As the raindrops fall, they wash the air, absorbing carbon dioxide and reaching the earth as a mild solution of carbonic acid, or fresh water, needed for plant, animal, and human life to survive. Evaporation, condensation, and precipitation. These make up the water cycle, which is continuous, occurring over and over again somewhere every moment of every day. 3,000 years before the principles involved were discovered by modern science, the Bible described the water cycle with amazing accuracy. All the rivers flow into the sea, yet the sea is not full. To the place where the waters flow, there they flow again. Think of the energy involved. More energy is expended in the water cycle every 24 hours around the planet Earth than man has been able to generate throughout the course of history. And the water cycling process is so successful that up till now anyway, the most extraordinary thing about water is just how ordinary it really is. Vital to life, yet available in great abundance. And because of abundance, it's an easy thing to disregard the value of a substance. Ordinary water, how much would you say it's worth? Actually, it's priceless. Did you know it takes 300 gallons of water to make one loaf of bread? 700 gallons for 1 barrel of petroleum? 4,000 gallons for 1 pound of beef? 10,000 gallons for 1 automobile? Hay, dry as it may seem, is over 60% water. The same thing is true, only more so, of every tomato, every carrot, every apple. 250 tons of grain represent an intake of 150,000 million tons of water. Every day we buy products that are largely water, or it took a lot of water to make them. But even more important is the role water plays in the functioning of your own body. About 70% of the average human body is water. In one way or another, you keep losing this liquid, and if it's not replaced, and fairly soon, you will die. It's the water in your blood that carries it through 60,000 miles of arteries, veins, and branching capillaries. Water plays a major role in the digestion of your food. It serves to lubricate your joints. Your mucous membranes would dry up without it. Without water, your eyes would cease to function. As you work or exercise, it's the water that regulates your body heat through a process called perspiration. Right at this moment, as from the beginning of time, water is supporting life on Earth. And so far as we know, there is nothing else like it in the entire universe. It seems to have been expressly designed to make the planet Earth hospitable to life, your life. Even so, with the gift of water comes a responsibility. We've been so blessed with this gloriously abundant, yet tremendously vital substance that we drink it, bathe in it, walk through it, compete in it, take what we want out of it, dump what we don't want back into it, and hardly give it a second thought. Water, with its precise properties, is God's loving provision for our physical lives. God has also provided for our spiritual life. Long ago, Christ said, "If you knew the gift of God, and who it is who says to you, 'Give me a drink,' you would have asked him, and he would give you living water."